So picture this. You are sitting on your couch on a Tuesday evening, just relaxing, and you suddenly notice this distinct, really pungent smell of fish in your living room.
Which is, never a good thing.
Right. But your instinct might be to call a plumber or maybe check the trash, but do not do that. Your very first call actually needs to be to a licensed electrician.
It genuinely sounds like the setup to a bizarre joke, doesn't it?
It really does.
But it is, it's one of the most critical and, frankly, terrifying residential warning signs you can encounter. Because you aren't actually smelling fish.
You're smelling chemicals, right?
Exactly. You are smelling the chemical breakdown of heat-resistant plastic and resins.
Wow. Well, welcome to the deep dive, everyone. That fishy smell isn't yesterday's dinner. It's literally the wire casings melting inside your walls right now.
Yeah, which is an incredibly dangerous situation.
Oh, absolutely. So today we're pulling from this really fascinating stack of field guides, articles, and service reports from Burleson AT Electric. They were a professional electrical service company down in Texas.
Right. They see this stuff every single day.
Exactly. And our mission for this deep dive is to figure out why our modern, high-tech lifestyles are literally cooking our aging homes from the inside out.
Because they really are.
They are.
Yeah.
So we're going to look at the invisible infrastructure behind your drywall, the bottlenecks in your power supply, and how to ultimately transform your property's exterior into this secure, beautifully illuminated oasis.
And it's a journey we really need to take because electricity is, well, it's the ultimate background utility.
Totally. You just expect it to work.
Right. You walk into a room, you flip a switch, the lights come on. You never really think about the massive physical forces at play behind that wall.
Out of sight, out of mind.
Exactly. But these sources reveal this massive collision happening right now across the country. Basically, the infrastructure of the 1970s and 80s is being asked to run the technology of the 2000s and 20s.
And the physics simply do not add up.
No, they don't at all.
Okay, let's unpack this, because I think most of us listening understand the basic concept of a circuit.
Sure, power goes out, does a job, comes back.
Right. But what these sources highlight isn't a failure of the concept itself. It's a failure of the actual physical materials hidden behind the drywall.
Yeah, we're talking about, impedance, thermal limits, and the degradation of 40-year-old insulation.
Which is a recipe for disaster.
Precisely. The text points out that homes built before the 1980s are at a severe risk here. Let's look at the materials. A lot of those homes contain ungrounded knob and tube wiring.
Which is super outdated.
Extremely. Or worse, they have aluminum wiring. And the problem with aluminum is that it expands and contracts with temperature changes way more than copper does.
Wait, really? So every time power flows through it and heats up, it expands, and then when the power stops, it shrinks.
Yes, exactly. And over decades, that constant thermal expansion and contraction causes the actual connections, like at your outlets and switches, to literally wiggle loose.
Oh, wow.
Yeah, the industry term is cold creep.
Cold creep. That sounds ominous.
It is. Because when a connection gets loose, the electricity doesn't just stop. It has to jump, or arc, across a tiny air gap to keep flowing.
And that jumping creates heat, right?
Immense friction and heat. That micro-arcing is a massive hazard.
So that is where the fish smell comes in.
You got it.
It's not just a warm wire. It's a wire that is actively creating a localized thermal event, basically cooking the plastic insulation right around it.
Exactly. The chemical compounds used in electrical insulation, specifically these certain thermosetting plastics and resins, they emit a very specific amine-like odor when subjected to extreme heat.
And it smells just like fish.
Smells exactly like rotting fish, or, sometimes sulfur. But it is a biological alarm bell telling you that a wall fire is basically imminent.
That is terrifying. But here is where I get confused and honestly a bit frustrated with how we handle home maintenance in general.
How so?
Well, the sources note that people experience the warning signs, right? Frequent breaker trips, lights flickering when the AC kicks on, or maybe a switch plate that just feels warm to the touch.
Yeah, those are classic signs.
And they just ignore them. I mean, if my car engine started violently rattling, I wouldn't just, turn the radio up, I'd pull over.
Why do homeowners treat electrical infrastructure so reactively?
Because the infrastructure is invisible. Think about it. If a pipe leaks, you see water damaging your floor immediately, right?
True, you can't ignore a puddle.
Exactly. You are forced to act. But if a wire is micro-arcing inside a wall, you don't see the physical degradation until the plastic actually melts.
Which is almost too late.
It is often too late. The sources point out that this reactive mindset, waiting for a complete failure or seeing a spark before calling a professional. It's a massive gamble.
Because the damage builds up over time. Right. The physical degradation is cumulative. So delaying repairs on a warm outlet significantly increases the risk of a catastrophic wall fire. And at the very least, it makes the eventual repair far more complex and way more expensive.
And the sources raise a massive red flag about trying to be proactive in the wrong way, too. I mean, the DIY route.
Oh, absolutely. The DIY route is a
Oh,
nightmare.
The temptation, right.
Mhm.
You watch a 10-minute video online, you buy a $20 receptacle at the hardware store, and you think, hey, I could swap out this buzzing switch myself.
Which the text explicitly states is one of the most dangerous things a homeowner can do, not just physically, but financially.
Financially, because of the fire risk.
Partly, yes. Unlicensed DIY electrical modifications create hidden fire hazards because amateurs don't understand the nuances, like the torque specifications on those wire terminals.
You can tighten them too much or too little.
Exactly. Or they don't know the specific gauge requirements for the wire.
And if you make a mistake, you aren't just out the cost of the parts. The sources make it very clear. Unauthorized, unlicensed electrical work can entirely void your homeowner's insurance policy.
That is the staggering reality. If an amateur repair causes a localized thermal event that, say, burns down your kitchen.
The insurance adjuster is going to investigate.
Yeah, they definitely will. And when they find out the wiring wasn't done to code by a licensed contractor, they can legally refuse to cover the damage.
So you lose the house, and you lose the financial safety net. That's devastating.
It really is. It's just not worth the risk.
But let's say you do everything right inside the house.
Yeah.
You hire the licensed professional, you replace the old aluminum wiring, and your in-wall infrastructure is absolutely pristine.
Okay, best case scenario.
Right. But you still aren't safe if the primary bottleneck hasn't been addressed, because all that power has to flow through a central hub,
Ah, yes. The core of the home's electrical
the
system.
main service panel.
What's fascinating here is how the text frames the electrical panel. It's not just a distribution box. It's presented as a rigid mathematical limit.
Like a highway system, right?
Exactly like a highway system. A panel from 30 years ago is essentially a two-lane country road. It was designed for a few tube televisions, some incandescent light bulbs, and, a basic refrigerator.
But today, we are trying to merge 5,000 semi-trucks onto that two-lane road simultaneously.
That's a perfect analogy.
I mean, we have blistering Texas summers requiring dual HVAC units to run constantly. We have smart appliances everywhere. And the biggest culprit of all electric vehicles.
Oh, the EV revolution is completely breaking the math of older homes.
I bet.
The sources specifically zero in on this. Installing a level 2 EV charger is not a simple plug-and-play scenario. You can't just screw it to the garage wall and expect your house to handle it.
Because the older panels just don't have the capacity.
Right. A standard older home might have a 100-amp electrical panel for the entire property.
And let's do the math on that, because it's honestly shocking. A single level 2 EV charger can pull 50 to 60 amps continuously for hours while the car charges.
Exactly. So you are dedicating 60% of your home's total thermal and electrical capacity to one single device.
That leaves almost nothing for the rest of the house.
Nothing. If your air conditioner kicks on, which might draw, say, 30 amps, and someone turns on an electric oven or even a hairdryer, you have instantly exceeded the physical limits of the panel.
So what happens? Do the breakers trip?
The breakers will trip, yes. Or worse, the bus bars inside the panel will overheat and melt.
Which is why the text specifies that EV integration requires a 200-amp panel upgrade, plus specialized dedicated circuitry and a professional load calculation.
Right. The electrician is essentially doing the physics homework to guarantee your house doesn't become a bottleneck.
Okay, so you upgrade the panel. But upgrading that panel isn't just about raw capacity, is it? The sources talk really heavily about defense.
Yes, capacity is only half the battle. The other half is protection. The text details the absolute necessity of whole home surge protection.
Okay, let me stop you right there. Because I have surge protector power strips all over my house. I bought them for like 20 bucks each at the big box store. Isn't that enough defense?
Not even close. I mean, those power strips are designed to handle very minor fluctuations.
Like little blips in the power.
Yeah, little blips. But they're often too slow and just too weak to handle massive external surges. The sources are talking about surge protection installed directly at the main breaker box, the central nervous system itself.
Oh, so before it even gets to the wall outlets, how does that actually work mechanically?
Think of it as a high-speed pressure release valve for electricity. It uses components called metal oxide varistors, or MOVs.
MOVs, got it.
So when a massive surge hits, say, from a lightning strike or a severe utility grid fluctuation, that surge wants to travel down the wires into your home.
To fry my smart fridge, my EV, my HVAC?
Exactly. It wants to destroy all of that. But the whole home surge protector detects that overvoltage in a nanosecond.
It's a nanosecond.
Literally instantly. And it opens a bypass valve, shunting all that destructive energy directly into the earth grounding wire before it ever touches your breakers.
So it intercepts the spike right at the gate.
Yeah,
That is brilliant.
it really is.
And when you consider the sheer financial investment sitting in a modern home, I mean, $30,000 in appliances and tech, easily.
Oh, easily.
A single severe weather event can wipe all that out in a fraction of a second. Stopping it at the panel seems non-negotiable.
Exactly. So you've upgraded the internal capacity and you've built a defensive wall at the panel. But if we trace the power back even further, we hit another massive vulnerability.
Right, because you have this 200-amp beast of a panel, but it doesn't matter if the feed coming from the street gets taken out.
Exactly. Which brings us to the vulnerability of overhead power lines.
Delivering electricity through the sky has been the standard for, what, a century? But from an infrastructure standpoint, it is incredibly fragile.
It's basically a sitting duck.
Right. And here's where it gets really interesting. Because you are completely at the mercy of the environment, the text talks about high winds, heavy ice storms, and falling tree branches.
Yeah, those environmental factors are the primary cause of sudden service interruptions.
Which is why the sources strongly advocate for transitioning to underground utility connections. You are physically removing the vulnerability by burying the feed.
But they aren't just tossing a raw cable into the dirt, obviously.
Walk us through the mechanism of how this is actually done. I imagine it's pretty involved.
It's an intensive, highly regulated process. Electricians have to bring in heavy equipment to dig a precise trench from the utility connection at the street directly to your newly upgraded panel.
So straight shot across the yard.
Usually, yes. And inside that trench, they lay down heavy-duty PVC conduit. This acts as an armored tunnel.
Okay.
Yeah.
Makes sense.
Then, the electrical cables are pulled through this conduit.
So the PVC is the physical barrier against the elements.
Yes. It shields the sensitive wires from extreme temperature swings, ice, and wind. But it also protects against subterranean threats.
Like what? Moles.
Moles, gophers, squirrels. Burrowing wildlife can't chew through the PVC. And it provides a massive layer of defense against accidental landscaping interference.
Ah, right. If someone is digging a hole for a new tree.
Exactly. They will hit that hard plastic conduit with their shovel long before they slice through a live main power line.
Okay, I hear the safety benefits, I really do. But let's have a real conversation about the friction here. Trenching up your front yard is a massive disruption.
It is a big job, there's no denying that.
You have heavy machinery tearing up the grass, you're paying thousands of dollars for the labor and materials. Is the return on investment actually worth it, just to avoid a tree branch knocking out your power once every 5 years?
It is the most common pushback contractors hear, honestly. But the text offers a compelling counterargument that goes beyond just the utility aspect. It really comes down to property value and aesthetics.
Aesthetics.
Think about it. Look at any high-end, newly developed neighborhood today. What is missing?
The utility poles. The sky is completely clear.
Precisely. Moving those lines below grade removes the thick, ugly black cables from your sightline. You are essentially decluttering the sky above your property.
I never really thought about it like that, but it does make a huge difference.
The sources point out that this instantly elevates curb appeal. If you ever list that property on the real estate market, a clean skyline and an underground, weather-resistant tower feed is a major selling point.
So the ROI isn't just in fewer blackouts, it's baked directly into the equity of the home.
Exactly. It's an investment in the property's overall worth.
Okay, that completely reframes the disruption for me. It's an architectural upgrade just as much as an electrical one.
Absolutely.
So let's take stock of the property now. The ugly overhead wires are gone. The power supply from the street is armored in PVC underground.
Check.
The panel is a modernized 200-amp hub protected by a surge valve. The in-wall wiring is safe and cool. You essentially have a pristine, high-capacity blank canvas.
And that naturally transitions us from the invisible infrastructure to the visible aesthetic.
Yeah.
How do you actually utilize that robust power to enhance the exterior of the home at night?
Right. And the sources dive really deep into tailored outdoor lighting solutions.
Hey.
And what I appreciate is that they don't just, list products like a hardware store catalog.
No, they get into the strategy of it,
Yeah, they discuss the psychology of illumination.
which is so important because outdoor lighting is often done completely wrong by homeowners.
Oh, totally. The instinct for security is usually just to slap a massive blinding floodlight right over the garage.
Right. But from a strategic standpoint, that is completely counterproductive.
This was a huge aha moment for me in the sources. Blinding floodlights actually make you less secure because of how human optics work.
Yep. Biology gets in the way.
If you have a single massive point of harsh light, your pupils constrict. They shrink. So what happens to everything outside that narrow beam of light?
It becomes pitch black. You create these massive, impenetrable blind spots and really harsh shadows all over the yard.
And shadows are exactly what you don't want.
Exactly. The sources emphasize a psychological approach called layered lighting, or managing contrast ratios.
Yes. So instead of one big light, you use pathway lights, maybe some deck lighting, and subtle wall sconces.
Right. By distributing softer ambient light evenly across the property, your pupils remain relaxed. You eliminate the shadows entirely.
Because criminals are not deterred by a single light they can simply walk around or hide outside of?
No, they aren't. They are deterred by an environment where there is no physical shadow left to hide in.
That makes perfect sense.
And well-lit, evenly illuminated pathways and facades change the entire psychological profile of a property.
it just feels safer.
It does. For residential homes, it prevents tripping hazards. For property managers of apartment complexes, the text notes it is a primary driver of tenant satisfaction. People intuitively feel safer in environments with low contrast, even lighting.
And beyond security, there's the architectural drama of it all. The sources talk about accent lighting for large trees or custom landscaping.
Uplighting a nice oak tree looks incredible.
It really does. This is where you are drawing the eye intentionally, highlighting the textures of a stone facade or the canopy of a tree.
And we can't ignore the ambiance factor either. String or festoon lights over a patio create a very cozy, enclosed feeling outdoors.
I love those.
They're great. The text notes this is incredibly popular not just for backyards, but for local cafes and small businesses trying to attract foot traffic at night.
But how we control all of these layers has completely revolutionized.
Because it all ties back to the modern, tech-heavy home we built in the first half of this deep dive.
Exactly. If we connect this to the bigger picture, your outdoor lighting is no longer just a manual switch you flip when you hear a noise in the bushes.
Right. The sources detail the integration of these layered lighting systems with smart home technology. Because your panel can handle the load now and your wiring is secure, professional electricians can network all of these exterior lights together.
Which means full automation.
Full automation. You can set up precise astronomical scheduling.
Astronomical scheduling, meaning it tracks the sunset.
Yes. Your pathway lights can slowly fade up exactly at sunset based on your specific GPS coordinates.
That is so cool.
And then, say your accent lights dim to 20% at midnight to save energy. And you can override the entire system from your smartphone, whether you are sitting on your couch or in an airport across the country.
The energy efficiency alone is massive, especially when you pair that smart scheduling with modern LED fixtures.
Oh, the power draw is tiny compared to older halogen bulbs.
And the text notes a rapidly growing trend that takes this efficiency even further eco-conscious consumers shifting toward solar outdoor lighting.
I was wondering when solar would come into play. It makes perfect sense for outdoor spaces.
It really does. If you want to illuminate the far corners of a really large yard, trenching low-voltage wire all the way out there is expensive and tedious.
Right, running wire for hundreds of feet adds up.
But high-quality solar fixtures allow you to extend that ambient security perimeter without adding a single amp of load to your main panel.
It creates what the sources call a comprehensive lighting plan. You are basically blurring the lines between the interior and the exterior of the home.
So it flows naturally.
Exactly. When your kitchen lighting matches the temperature and quality of your patio lighting, and it all turns on seamlessly at dusk, your living space literally feels like it extends right into the outdoors.
So what does this all mean? If we step back and look at the whole journey today, ensuring your home is ready for the future requires a total shift from reactive to proactive thinking.
It really does. You can't just wait for things to break anymore.
Exactly. It means listening to the physics of your house. If you smell that fishy plastic odor, you understand the mechanism now? It's the chemical breakdown of failing infrastructure.
Don't ignore it.
Right. And it means doing the math on your panel to ensure your EV charger isn't starving your air conditioner. It means defending your investment with surge valves and putting PVC conduit underground.
Setting the foundation.
Setting the foundation, yeah. And finally, it means using that reliable power to strategically and beautifully paint your property with light, removing shadows, and extending your living space.
It is a total evolution of the residential property. And, looking at the trajectory of these sources, especially the push toward high-capacity EV batteries in the garage and independent solar lighting out in the yard, we are essentially watching homes transition from passive consumers of electricity into decentralized energy hubs.
Decentralized hubs. That's a fascinating way to put it.
It really raises an important, almost inevitable question for the future. As battery technology improves and we generate more and more power on site, how long will it be until we don't need to pull from those massive city power grids at all?
That is a brilliant thought to end on. We might be trenching lines today just to abandon them entirely in a few decades.
It's crazy to think about.
It really is. Well, thank you for joining us on this deep dive. Take a walk around your property tonight, look at where the shadows fall, check your electrical panels capacity, and maybe take a closer sniff near your older outlets to make sure your walls aren't trying to tell you something. We'll catch you on the next deep dive.